Let's talk about question 4 in the 2021 exam 2 paper under networks. Roadworks planned by the local council require 13 activities to be completed. The network below shows these 13 activities and their completion time in weeks. What's the earliest completion time of activity K? The earliest completion time comes from the forward scan, and so when we do that, in doing a forward scan, where multiple edges meet at a vertex, there are choices to be made as you go forward. For example, this edge and this edge come to this vertex, again these two here and those two there. So when making a choice at these vertices, you have to choose the larger value as you do the forward scan. I write a box at each one of those vertices. This is a bit tricky here. So when doing that, you put a 0 to start here, and we go along A. I write 6 here because that's a place where a choice has to be made of the larger value. And then I go along B, that's 3, and 3 plus 2 along C is 5. The larger value here is 6. If you go along E, 6 plus 5 is 11. And then 11 plus 2 is 13 here. If you go along D, 6 plus 3 is 9, and 9 plus 4 is 13. And as both the values are 13, we write 13 here as the earliest start time for L, and 13 plus 5 along L is 18, again a choice here. And let's come along I, 11 plus 2 is 13, and the larger value here is 18, and 18 plus 1 is 19. Coming along F, 3 plus 5 is 8, and coming along J, 11 plus 3 is 14, and the larger value is 14, and 14 plus 3 is 17. Of these two values, it's 19. Now let's look at the earliest starting time for activity K. So that's K, and the earliest starting time for is 14. How many of these activities have 0 float time? So in order to have 0 float time, they should be on the critical path. So in order to get a critical path, we have to do a backward scan as well. For the backward scan, we start with 19 here and along M. Now in the backward scan, we can see that we'll have to make a choice here. One here too. Another here, because as you come back along the direction of the arrows, these are the vertices at which multiple edges meet. And here. So let's start with 19. 19 take away 1, which is the duration of M, gives you 18. And then if you go along L, 18 take away 5 is 13. And then 13 along H, take away 2 is 11. So going along I, 18 take away 2 is 16. And 19 along K, 19 take away 3 is 16. And then along J, 16 take away 3 is 13. Of these three values, the smallest value is 11, and that is my backward scan value. Now we go along G, 13, take away 4 is 9, and then along D, 9 take away 3 is 6. Coming back along E, 11 take away 5 is 6 also. And so the choice is 6. Now coming back from through F, 16 take away 5 is 11, and coming along C, 6 take away 2 is 4. The smaller value is 4. And then along B, 4 take away 3 is 1. Coming along A, 6. This 6 take away 6 is 0. The smallest value is 0. So that's basically a network with a forward and a backward scan, which will help us find the critical path. So the critical path is one where one is both the boxes are the same, for example this, and secondly, usually go along the paths by adding the earliest critical path to activity completion time to get the next earliest critical path, earliest start time, sorry. So if we were to take 0, and to that 0 we add 6, we get this one, 6, 6, which is good. And then 6 plus 3, if we go along D, gives you 9, which is, and both the boxes are the same, which is good. And 9 plus 4, this 9 plus 4 is 13, so that gives me another 2 same boxes. And 13 plus 5 is 18, and 18 plus 1 is 19. So the activities that form the critical path are A, D, G, L, M. So this is one set. Now if I see that there are more boxes, for example, here there is a box with both 11, 11. So that implies that I can actually find another critical path which includes some other values. So let's see what we can do about that. Now 0 plus 6 is 6. 6 plus 5 is 11. 11 plus 2 is 13. And 13 plus 5 is 18. And 18 plus 1 is 19. So clearly, there are multiple critical paths over here. So one of them is A, D, G, L, M. And the other one is A, E, H, L, M. So they're asking you how many of these activities have 0 float time. That implies that these activities on the critical path will have 0 float time. They don't have time which can be delayed. The activity has to start straight away. So if you count the number of different activities here, you will find there are 7 activities. Because along these paths, there are some that so besides these 3, there are D, G, E, and H, 4, and that makes 7 activities. The next question says, it is possible to reduce the completion time for activities A, E, F, L, K, and the reduction time of these 5 activities can incur an additional cost. The table below shows these 5 activities that can have their completion time reduced and the associated weekly cost in dollars. So the completion time for each of these activities can be reduced, very important, by a maximum of 2 weeks. The overall completion time can only be reduced to, so they're giving you the maximum reduction it can go down to is 16 weeks. And so what's the minimum cost of this change in completion time?